Landfill. It burdens and damages our environment with gas and leached groundwater. However, waste isn't really just rubbish. It's a mixture of raw materials, energy, and water, which are all recoverable. If we burn it, it's the same as if we were throwing valuable materials and water into the fire. Our goal is to take out the water, separate out non-combustible materials, and create a source of energy from the remaining 50% of combustible materials. In order to reach this goal, the Herdhof-Stabilate process was developed in Aslar, Germany in 1997. Since then, further plants have been built across Germany to treat household and commercial waste. The basic principle of the method is to first dry the waste biologically, then separate it mechanically, and finally recover raw materials and create a source of energy. The entire process is automated. In this system, people have next to no physical contact with foul-smelling rubbish. Step 1 of the process. The waste is shredded. Decaying and fermenting rubbish cause damp waste to become sticky. This must be stopped. Therefore, we move to step 2. Computer-controlled cranes drop the waste into the so-called Herdhof boxes. Here, the water is removed. The remaining dry waste can now be separated. The computer ensures that each box is filled with the same amount of waste. In the Herdhof boxes, microorganisms break down decaying or fermenting organic waste in a controlled way. The rubbish becomes biologically stable. For 7 days, the instruction is, keep the lid on. Fans blow air from beneath the boxes to ensure that the microbes in the box have the right conditions. When the organic content breaks down, it heats up the waste. The injection of air controls the decaying process. The process air is charged with moisture and waste gases, which flow out of the boxes. Process air and wastewater are then treated. A noteworthy advantage of this process is that it is already geared to the highest standards for the protection of the workplace and the environment. The moisture is condensed over a heat exchanger and is subsequently filtered and cleaned. Only then is it put back into circulation. This is another reason why the Stabilate process has a head start. Over the coming years, European and worldwide standards will become more and more aligned. Not only for wastewater, but also for process air. The process air contains toxic and organic particles. These are burnt by LARA, the thermal oxidizer. Nothing which can damage the environment survives the combustion chamber, heated to over 850 degrees Celsius. This meets the highest German and international standards. After 7 days, the decaying process is completed. The waste is now dry and is more hygienic and looser than raw waste. Here is the comparison of the combustion values and the heavy metal content before and after the drying process. Of course, the heavy metal content is the same. Time for a completely new step. This is the second key core element of the Stabilate process waste separation. The dry and shredded waste is carried on conveyor belts to the vibrating sieves. Lighter, combustible materials like wood, paper, and plastic are blown into the air. In order to obtain a higher quality for this particular fraction, metal such as aluminum foil is further separated out. Stabilate has an unrivaled position both in terms of its calorific value and its low heavy metal content. It has twice as much energy as raw waste and can therefore be used as an alternative to high-quality coal. With vibration comes dust. The air system and conveyor belts are enclosed, as are all units in the Herdhof Stabilate system. Filters remove the dust. This is a process which has been really well thought out. Let's go back to the non-combustible components in the waste. Whether it's a spoon, a cup, or a beer can, practically everything can be sorted mechanically. The process separates ferrous and non-ferrous metals from the mineral fraction by the use of magnets and eddy currents. The only things that must be removed from the ferrous stream by hand are old batteries. The separated metal fractions are recycled. This is a further environmental plus. Recovering aluminum from waste materials conserves energy. Producing aluminum from bauxite is energy intensive. The remaining fraction can be used as cover material or further cleaned for use in road construction. However, our process can do even more. Opaque and transparent mineral waste is separated by light. In the space of a millisecond, glass shards are blown from the stream by air jets. In order to recycle old glass, it must meet high purity standards. This system even solves the problem of colored glass. The remaining sorted glass meets the quality levels demanded by the glass industry, i.e. a maximum of 25 grams of foreign material per ton of glass. This is the material from which rubbish heaps are made. It's too valuable to dump on a landfill. The quantity of recycled minerals and metals is impressive, even more so if one takes into account the environmental benefits. However, the impact on the recycling of energy is even more impressive. Stabilate can be used as a substitute for fossil fuels and so decreases CO2 emissions. It consists of 2/3 organic material, e.g. wood, paper. Of the remaining 1/3, approximately 10% are plastics, approximately 25% are fossil fuels like rubber and synthetics. Less than 1% in combustible material is left over. Stabilate has already proven its effectiveness as a fuel. For example, in the power station beside the plant in Adalah, called EVA. Here a dream has become a reality. Energy is produced from prepared waste in a small plant according to the local need. This provides a model for the future decentralized provision of power and heat. The system fully meets the standards for environmental protection. But Herhof is already thinking beyond the EVA power plant. For example, the use of Stabilate as an environmentally friendly alternative in cement works and coal-fired power stations. Indeed, its use as the base for fuel of the future. Fuel cells will soon become important sources of energy. They need hydrogen or methanol. In this plant, the required raw material, synthetic gas, is being made by the Stabilate. The project of the future is the IPV plant. Recovery instead of burial. Recycling instead of landfill. In Rennerode, in Germany, the Herhof process is even being used to remediate parts of an old landfill. This directly benefits the countryside and the local population. Adalah has become the plant that recycling experts across the world want to visit. Dresden is the first major city to treat its waste in a Stabilate plant. The success of this process has now gone well beyond the borders of Germany. This is a process which works. It makes ecological and economical sense, and it may well be the solution you are looking for.